Hi, this is Hilal. In this video on Mathematical Economics series, we will solve a problem that was asked by a brother regarding Cournot duopoly model, how to find the Cournot equilibrium. And in this question, we have to compare the Cournot equilibrium with a perfectly competitive outcome. Okay, that means when the number of firms are large, what will happen to the Cournot equilibrium? The question is like this: market demand is given by, we are being given the Cournot duopoly model in which we have two forms. Market demand function is given by P is equal to 140 minus Q, where P is the price, Q is the total output. Okay, and if P is less than 140, our demand function becomes this, and it is 0 if otherwise. That means if Q is greater than 140. There are two firms, each firm each with unit cost of $20. So marginal cost is same for the two firms. We have to compare the Cournot equilibrium with the perfectly competitive outcome. In the earlier video, I have calculated the Cournot equilibrium for this very question. You can check in the description box also, and I will put it in the I button, okay, in of this video. Okay, now let us see what will happen to our Cournot equilibrium when we have many number of identical firms. That means if there are large number of firms, what will happen to our Cournot equilibrium? Okay, now if there are, let us say, I will write, let us say we have n identical firms. Okay, n identical firms. Okay, then what will happen to the price? What will this price function become? So we have P inverse demand function will become 140 minus, so in place of Q we have n number of firms. I can write it like this: Q1 plus Q2 plus so on up to Qn. Okay, this is inverse demand function. If we were having only two firms, as we have shown in the earlier video, then this demand function would have become P is equal to 140 minus this Q1 plus Q2. Okay, also we are being given that marginal cost. So let me write here, marginal cost is given as 20. I will write here 20. Okay, now to find, first we need to find the reaction firm. Okay, reaction function rather. Okay, we will try to find the reaction firm, reaction function for the ith firm. Okay, for that we need to find the total revenue. Okay, so total revenue for ith firm is equal to, so if we have n identical n identical firms, so if we want to find the reaction function for ith firm, okay, then first we need to find the total revenue of the ith firm. So it is simply price into quantity produced by ith firm. Okay, this is the function for total revenue. Price into quantity gives us the uh, total revenue. Okay, what will be the total cost? Total cost for ith firm is simply the marginal cost, that is C into quantity produced by the ith firm. This is total cost, this is total revenue. Okay, now then what will be the profit for the ith firm? So profit is simply, profit for ith firm is equal to, so total revenue minus total cost. We know pi is equal to TR minus TC. Okay, total revenue is this P into QI. So in place of P, I will write this very inverse demand function. So we have 140 minus Q1 plus Q2 plus so on up to Qn. Okay, and to this we have to multiply QI. Then we have to subtract the total cost, that is C marginal cost is 20 into QI. This is our profit function for the ith firm here. Okay, now let's try to rearrange this. We can write it like this: this QI is multiplied to each of these terms, so this will become 140 qi. Okay, then we have minus q1 into qi. So this qi is multiplied to each of these terms. Obviously we have negative sign for each term here, so we have q2, okay, qi minus up to, then we will have another qi square. Why it is here qi? So I will write here, I forgot to write here. So one form which we have here, that is qi, will be also one form here up to qn. Okay, now qi into qi is qi square uh, minus up to qn qi. Okay, then we have 20 qi. This is our profit function. Yeah, I will try to make it here clear how does this qi came here. Since we want to find the profit for either firm, so what will be our firms? Q1, Q2, so on. One firm will be also Qi up to Qn. Okay, so I forgot here, so I multiplied Qi with Qi to get Qi square. This is our profit function. Now first order condition for profit maximization requires, that is, first order condition for profit maximization requires that the derivative of, that is, d pi upon di dqi, that is the derivative of profit function with respect to quantity produced by the ith firm, should be equal to 0. That means we need to differentiate this profit function partially with respect to qi and set it equal to 0. So we have d pi upon, so let me write it here, take the derivative of this function with respect to qi and set it equal to 0. So the derivative of qi is 1, we are left with 140, minus here we will get q1 because the derivative of qi is 1, minus q2 minus the derivative of qi square is, this square will become coefficient, so this becomes 2 qi, okay, by power function rule, minus the derivative of qi is qn. Similarly here the derivative of qi is 20 and we set it equal to 0, obviously. Now just rearrange this. We have 140 minus 120, this comes out to be 120. Okay, I can write 120. If I write it like this, 120 minus q1 minus q2 minus up to 2 qi minus up to qn is equal to 0. Now if I try to solve it for qi, so if I transpose this term on RHS, so this will become minus 2 qi will become plus 2 qi. So I will write here a 2 qi is equal to 120 minus q1 minus q2. Since we have taken this out, what are we left with? So we will have here qi minus 1, one form will be this, plus qi plus 1, because qi term we have transposed it to LHS up to, so let me write it here, it is here minus, okay, then we have minus, so on up to minus qn. Okay, now let us solve it for qi. That means qi is equal to, if I transpose this 2, it will get divided, so we have qi is equal to 120 minus, let me take minus common, so we have q1 plus q2 plus so on to qi minus 1 plus qi plus 1 plus up to qn. Okay, so obviously dividing by 2. So this comes out to be 120 upon 2 comes out to be qi is equal to, this is 60 minus 1 upon 2. We have q1 plus q2 plus qi minus 1 plus qi plus 1 plus qn. Okay, so this is the reaction function for ith form. And what is the reaction function? It is simply the best response for firm I in terms of output for any output level decided by the other firm. Okay, so this is the reaction function in this case, and we also call it the best response curve. Okay, now this is the quantity produced by ith firm. Okay, now since we assume that we have n identical firms, here we will also assume that all firms have same cost. Okay, if all firms have same cost, they will obviously produce same level of output. Okay, so I will write here, if all firms, if all firms have same cost, okay, they will produce, so will produce same level of same level of output. That is, we can write it here, that output produced by first firm is equal to output produced by second firm is equal to output produced by a third firm is equal to output produced by ith firm. Let us say it is equal to q complement. Okay, we assume that all firms have same cost, they produce same level of output, then output produced by each of the firm, let us denote it is same, and we denote it by q star, sorry, q dash. Now we can write qi is equal to q dash here. Okay, so in place of qi we have q dash. Now what will happen then if it is the case? Then q dash, this in place of qi I will write q dash. Okay, so let me write here, in place of qi I will write q dash. Q dash is equal to, okay, q dash is equal to 60, we have 60 minus 1 upon 2, 1 minus upon 2. Now how many firms we have here? You can see we have here n minus 1 firms on RHS, because one firm we have taken it to LHS. So can I write here n minus 1 q dash? Okay, let us try to figure this out. I have written in place of qi as q dash, as I assume that all firms have the same cost and will produce same level of output. Now this function will become, so in place of qi I have q dash is equal to 60 minus 1 upon 2. Now what is, how many firms we have here? We have n minus 1 identical firms. So in place of q1 q2 qi minus 1 qi plus 1, I can write n minus 1 into q dash, because q1 is equal to q dash, q2 is equal to q dash, and we have these forms up to n minus 1 number of times. Okay, so let's solve it again. For q dash, it is getting lengthy here, so I cannot do anything. I just want to explain it to you guys. Okay, so we have 60 minus, I can write it like this, let's multiply this 2 to this, it will become 120 minus n minus 1 q dash upon 2. Okay, which gives us this, if transposed, this will become 2 q dash is equal to 120 minus n plus 1, sorry, we have minus n into q dash plus q dash. Okay, now transposing these terms, we have 2 q dash minus q dash plus n q dash is equal to 120. So 2 q dash minus 1 q dash is equal to q dash plus n q dash is equal to 120, or q dash, if we take it common, we have n plus 1 here is equal to 120, or q dash comes out to be 120 upon n plus 1. Okay, so q dash comes out to be n plus 1 here. Okay, now we can substitute q is equal to, we can substitute in place of q, where we have this demand function. The original demand function is this. Okay, this is p is equal to this very thing. In place of let me write it here. So p is equal to 140 minus q. This is the total output. Now in place of this q, this is the total output of all the firms. So in place of q, cannot I write nq dash, because this is the output produced by one firm and all firms are identical. Then in place of this, I can write nq dash, because it is total output. This is the output produced by one industry, one firm, sorry, and each firm produces same level of output. So I can write in place of q, I can write in place of q, I can write nq dash. Okay, nq dash. I hope I am making myself clear. This is the total output, and this is the individual output of each firm multiplied the number of firms. So these two will be same here. So then what will happen? What will our this inverse demand function will become? So this becomes p is equal to 140 minus n q dash. Simple. Okay, so we have p is equal to 140 minus n in place of q dash. In place of q dash, we have this function for each firm. So we have 120 upon n plus 1. Okay, or we can write it like this. It is equal to 140 minus 120 n upon n plus 1. This is our demand function. So let me write here. Now total profit will be equal to, what will be the total profit? Total profit is equal to, let us say, pi subscript to t denotes total profit, is equal to simply price into quantity minus c into q, marginal cost into the quantity produced, and this comes out to be p into q. So we have p in place of q, we have nq dash. So I will write here nq dash minus c in place of q, we have nq dash. Okay, now just plug in place of p, we have this very function. So I will write here, let me write this. We have 140 minus 120 n upon n plus 1. Okay, so this is p, then we have n, then we have q dash. In place of q dash, we have 120 upon n plus 1. Then we have minus, marginal cost was 20, so I will write here 20. Then we have n, then we have q dash. So in place of q dash, we have this 120 upon n plus 1. Okay, so this will be our total profit. Okay, now let's solve it out. If we take this function, that is n into this term, actually, if I take this term common, okay, that means pi t will become, if I take it common, So what I am taking common? I am taking common, uh, hmm, let me write 120n upon n plus 1. I am taking it common. Then we are left with 140 minus 120 n upon n plus 1. Okay, then we have minus, if I write this term, I have taken this out, I have also taken this out, so we are left with 20. I hope I am making myself clear here. So we can write it like this. We have 120n upon n plus 1. So in place of 140, in place of this term, this comes out to be 140 minus 120. It comes out to be 140 minus 20 comes out to be 120 minus, we have 120n upon n plus 1. Okay, now let's make the denominator of this term also is n plus 1. So for that, what we need to do, we have 120n upon n plus 1. So making denominator same, we have 120, I can multiply it by n plus 1. We have n plus 1 here minus, then we have 120 n upon n plus 1. I was just getting nervous, can I save the space, but unfortunately I cannot save the space here. Okay, so let me write it without any fear. So I have 120 n upon n plus 1. Now what is this? This is 120 n plus 120, this term if I expand, minus this 120n. Why I am subtracting? Because we have the same denominator, we can subtract to the numerator. So we have 1 common n plus 1 in the denominator. Okay, now what is this here? We have 120n upon n plus 1. We are left with here this, these two terms will get cancelled. We are left with 120 upon n plus 1, which comes out to be 120 into 120 comes out to be 144. 12 12s are 144. Then we have two zeros, and then we have n upon n plus 1. N plus 1 is n plus 1 square. Okay, this is our total profit. Total profit when we have n identical firms. Okay, we also got price, we also got quantity here. Okay, now what we need to do, we have to see the things in a broader scenario. Now what will happen to our price, to the output, and to the total profit. Okay, for that, what can I do? What should I here actually, let me rub this out here. Okay, sorry for the lengthy video, it is not in my hands. Now let us try to figure this out here. What we got, what things actually we got here. We got price, we got P is equal to 140 minus 120. Okay, n upon n plus 1. Okay, we got when we have n number of firms in a Cournot equilibrium. Okay, so this is the price function. Now what happens if n becomes large? Let us say when n tends to infinity, when we have infinite number of firms, then this expression, that is limit as n tends to infinity n upon n plus 1, this comes out to be 1. Okay, so I can show in another video how this comes out to be 1. So this term comes out to be 1. When n tends to large, becomes infinity, then our price will become 140 minus 120, which comes out to be 20. Okay, here you can understand we got price is equal to 20. Okay, our marginal cost is also 20. Profit maximization in perfect competition requires that price should be equal to marginal cost, and we got that very result here. We can say when the number of firms becomes infinite, this Cournot equilibrium tends to be a perfectly competitive outcome, because we have to prove that price is equal to marginal cost when the number of firms in Cournot equilibrium becomes very large, and when they become large our price was is equal to marginal cost. Why? Because marginal cost was 20. Also we got 20 as the price when n tends to be infinite. Okay, this is the one condition. Second condition is, let me rub this out also. Second condition for perfect competition is that firms earn zero profits in long run, obviously. Now, what is the profit function here? Profit, total profit. We have got it. It is 14400. Okay, n upon n plus 1 square. Okay, this is the profit function when we have n identical industries. Okay, sorry, n identical firms. Now let us see what will happen if the number of firms becomes infinite. Okay, that means if this term becomes infinite, that is limit as n tends to infinity, n upon n plus 1 square. Okay, when this tends to infinity, it comes out to be, the value of this comes out to be 0. Okay, and I will explain in another video if I have time how does this term comes out to be 0 and how does this term comes out to be 1. Okay, so let's remember it here, because I have no space available and the video is getting very long. That means when n tends to infinity, total profit total profit is equal to 14400 into this term has come out to be 0, that is equal to 0. That means profit profit is when we have infinite number of firms in Cournot equilibrium is 0, and this is the same condition for perfect competition. In perfect competition we have the 0 profits. Okay, in the long run. So first condition we got price is equal to MC in the Cournot equilibrium. Second is that the firms earn 0 profits. Okay, we got the two things here. Also here we got price is equal to marginal cost is equal to 0. So we can safely say, thus we can safely say that when number of firms becomes infinite, when we have infinite number of firms, Cournot market, Cournot, Cournot equilibrium or Cournot market approaches to approaches to perfect competition. Okay, perfect competition. Okay, I hope I make myself clear in this video. If there are some mistakes in explaining that video, you know, it became very large in terms of the mathematics being involved. Okay, so please share and subscribe this video with your economic friends. That is the only motivation for me keep going on. Okay, now in the third part we will see what will happen to the Cournot equilibrium when we have only one firm. Okay, so we have to compare Cournot equilibrium with the monopoly outcome. Okay, Thank you. Have a nice day.